are solving equations. You have solved equations for forever. Is there a problem? Oh, an extra? Thank you. You have been solving equations since shortly after you figured out what x was, or what x meant. You started solving equations that looked like this. Remember? You even probably solved equations that looked like this. Yeah? That's probably the first way you ever saw solving an equation. Well, now you've solved all kinds of equations now. And now you get to solve a new kind. And they're equations that have trig in them. Now, I just got insulted. Consider the trig equation secant theta equals 2 root 3 over 3. The plan outlined below is the process that you will perform when solving a trig equation that looks like that. Now, we are looking for two values of theta such that the angle is somewhere from 0 to 360 degrees without a calculator. All right? Now, I'm just going to tell you, I don't use his steps when I solve trig equations. But we're going to go through it the first time using his steps. All right? Look at the first thing, the first item. If necessary, rewrite the equation in terms of sine, cosine, or tangent. Remember I told you I don't want to work with secant, cosecant, and cotangent? Oh, but what do I know about secant? Not opposite. Reciprocal of what? So, what is the cosine of theta then? Now, I know I've told you that you don't have to rationalize. When you have an answer that has a radical in the denominator, you don't have to rationalize. In a lot of these, it's going to be really helpful if you do. How would we rationalize this one? Multiply top and bottom by root 3, good. What do I get? Which simplifies to square root of 3 over 2. Look out. Look out. Lily knows what that is. Now, cosine of theta is the square root of 3 over 2. Now, when you solve this equation, what you're looking for is what is theta? What angle or angles have a cosine that's square root of 3 over 2?
60.
Try again. Now, oh, the other one, yeah. Now look at number 2. Make a note of the two possible quadrants of termination for theta based on the sign, S-I-G-N, of theta. He really means of the trig function. Is cosine theta positive or negative? What two quadrants have a positive cosine?
1 and 4.
So, I know that my angle is going to be in quadrant 1 and quadrant 4. Now, I need you to understand this. There is an angle that terminates in quadrant 1 that has a cosine of root 3 over 2, and there's an angle that terminates in quadrant 4 that has a cosine of root 3 over 2. We got to find them both. Now, take the inverse trig ratio of both sides to find an angle that satisfies the equation. Since you're doing this without a calculator, the angle should be an angle on the unit circle. How do you undo multiplying by 2? Divide by 2. How do you undo adding 3? Subtract 3. How do you undo cosine? Are secant and cosine inverses? They are reciprocals. They are not inverses. The inverse of cosine is cosine inverse. Okay? That's just real clever. You do not need to worry about that until you go to your calculator, which we are not going to do right now. Here's what I need you to think. Quadrant 1. What angle in quadrant 1 has a cosine of square root 3 over 2? What angle in quadrant 1 has a cosine of square root 3 over 2? 60 degrees. No, 30 degrees. My bad. 30 degrees has a cosine of square root 3 over 2, right? Now, we're being asked to do this one in degrees, aren't we? So guess what? 30 degrees is one of my answers. Because I was supposed to find an angle in quadrant 1. What other quadrant do I need to find? Now, how am I going to find an angle in quadrant 4 that also has a cosine of square root 3 over 2? I'm just going to use a reference angle of 30 degrees in quadrant 4. So what I'm going to have an angle. No? Look, I'm going to have a reference angle of 30 degrees. So what's my red angle? 330 degrees. I've solved this equation. Cosine theta equals root 3 over 2 when theta equals 30 degrees or 330 degrees. We just solved that equation. Are there more angles than just these two that have a cosine of root 3 over 2? How many? An infinite number of them, because what kind of angles could we look for? Coterminal, right, because any angle that's coterminal to one of those will have the same cosine. But if you'll notice, this one was only asking for answers on that interval, okay? All right. Next page. This one, you're going to have your calculator. What's the matter? Did I skip something? Oh, I sure did, didn't I? Oh, shush. Use the plan described above to solve this equation. Sine theta equals negative root 3 over 2. Show your analysis. Here's what I want you to do. Not crooked like that. I think that's probably pretty crooked. Okay. The first thing I want you to do is decide what quadrants your angle could be in. Is my sine of theta positive or negative? What quadrants have a negative sign? 3 and 4. Boy, that's really crooked, isn't it? Oh well, we're just going to pretend it's not. I got to find two angles. I got to find one that terminates in quadrant 3 and one that terminates in quadrant 4. You with me? Now, this is the part that I need you to think about. Always go back to quadrant 1 because that's the one that you learned with your hand. What angle in quadrant 1 has a sine of square root of 3 over 2? 60 degrees. So 60 degrees will be my reference angle in both of those quadrants. So let's go to quadrant 3. If I have a reference angle of 60 degrees, what is this angle? So theta could be 240 degrees. And then we're going to draw, and we're going to put a reference angle of 60 degrees into the other quadrant that it could be. What is that angle? There are your answers. The sine of the angle, this just says that the sine itself is negative. It doesn't say that the angle measure is negative. Now, and the only reason I was told, well, shoot. I'm trying to get right up there. I was told to be on this interval, which does not include negative angles. Okay? What did I put? Well, why did I put 360? Thank you. All right. It's going to be quicker for me to work on my own calculator than to pull up the calculator here and go back and forth, because I don't think you're going to need to see keystrokes. Solve each of the following trig equations, finding two values of theta, and look at the interval we're on. Give your answers to the nearest thousandth of a degree. How many places? 3 places. Is the sign of theta positive or negative? What quadrants have a positive sign? 1 and 2. So I've got to find an angle in quadrant 1, and I've got to find an angle in quadrant 2. Now you say, well, I need it to say theta equals, right? So to get rid of sine, I'm going to do sine inverse. So what I'm going to write down, and I want you to write down this step right here. You write that down. What mode do you need to be in on your calculator? You be in degree mode. Does everybody see sine inverse? It's second sine. Well, it'll help if you type it in right, dum-dum. 47.307 degrees. What quadrant is that one in? That's in quadrant 1. How am I going to find the angle in quadrant 2? Good. I'm going to use that as the reference angle. 47.307. Say again. How'd you get it? Perfect. If you do 180 minus answer, then your other theta, 132.693 degrees. Do you have questions there so far? Easy? Or are you thinking, when's the hammer going to fall? Is that what you're thinking? When's it going to get hard? Next one. Cosine of theta is negative 0.482. What quadrants? 2 and 3, good. Now, hold it. What's theta? Yeah, what's theta without your calculator? What would I write based on what I wrote over there? Yeah, and I wrote too big. Theta equals cosine inverse of negative 0.482. Do that on your calculator. You get 118 degrees and some change. That's right, that's not a reference angle because, good, it's not acute. So what quadrant does this end up in? Is that a quadrant I need? Yes, so that's one of my answers. 118.816 degrees. How in the world then do I find the angle that terminates in quadrant 3? How do I find that angle right there? How do I find my blue angle? Look, let me just do it up here. This angle right here is this, correct? 118.816? That's right. Find that reference angle. 61 what? 61.18 61.184 degrees. Right, because then what's this blue reference angle? The same thing. Good. 180 plus that. We good? Does that make sense? So far. Okay, so far. Well, I think we're more than halfway through the notes already, aren't we? No. No. All right. Cosecant theta. I got to make myself notice something. Cosecant theta is that. So what do I know? Reciprocal of sine. So what is the sine of my angle? Well, we got to do one other thing first. Where could my angle terminate? Or, excuse me, where will my angle terminate? Quadrants 3 and 4. So I got to find an angle in each of those quadrants. So theta is, and I want you to write this step down, sine inverse of, and we'll go start finding theta. Dang, you're faster than I am. 1.235. Negative 54. Got a problem. So let's talk about what we figured out right there. Well, that's a good question. So here's what we figured out. We got an angle right here, right? That's negative 54.068. But what do I need? I need that angle. So, go ahead. That's right. You better be careful because what you've got sitting on your calculator right now is a negative number. Why do we have to add 360? Just add 360 to it. So just put plus 360. So that blue angle, do you agree? That's my quadrant 4 angle. Now I need an angle in quadrant 3. How in the world am I going to find an angle in quadrant 3? That angle right there. You betcha. I'm going to use 54.068 as my reference angle. Good. So I'm going to go find that angle right there. And what do you get? There are your angles. How could you check them? Well, I'd take the sine of those angles and then I'd take the reciprocal and I'd see if I get that. Right? Are you okay so far? Questions? Okay, we got a fourth one there on that page. Tangent. In this case, tangent is negative. Where are my angles going to be? 2 and 4. Without typing anything into your calculator, what is theta? What's the exact answer? Tan inverse. Okay, just run it and see what we get. What quadrant is negative 41 degrees in? That's in the fourth quadrant, but does it have a name that I'm happy with? No, that's negative 41.733 degrees. I need that angle. And you're getting that by doing what? Adding 360. So theta is 318.267 degrees. Are you okay? Where else do I need this angle to be, to terminate? Quadrant 2. How am I going to do that? And my reference angle is going to be this 41. So I'm going to have my angle sitting right there. That's 41 point, good, 733 degrees. And I want that angle right there. Perfect. 180 minus that reference angle. Don't forget your degree symbols. Are you going, oh, that's pretty cool. I can do this. I got this. Next page. Oh. What's different in these instructions than in the previous instructions? Radians. Change calculator to radian mode. Radian mode. We need to find two answers, two angles that make each of these equations true, and we're going to round our answers to the nearest thousandth of a radian. Are we going to put a degree symbol at the end of our answers? No, because we're radians, not degrees. Does radians have a symbol? No. So, some people might put RAD behind it, but no, no symbol. Okay, what quadrants? Two and three. All right, let's start with quadrant 2. I need an angle here. Right? What's the exact value of theta? Perfect. Run that on your calculator. What did you get? What quadrant's that in? That's radians, right? What quadrant's that in? Oh, huh? Why? Two pi is all the way around. So pi is how far around? Halfway. This angle's in quadrant 2 because it's a little bit less than pi, which is 3.14. Now, you've got a lot of space at the bottom of this page, right? Go down there. This doesn't have to be big. We're going to write some angles in radian measure. But now we're going to write them in radian measure again, just without the pi. Go to your calculator, do pi divided by 2. So if you get an answer between 0 and 1.579, what quadrant are you in? 1.571? My bad. I can't hear. Okay. So if you get an angle that's between 0 and 1.571 and you're in radian mode, what quadrant are you in? You're in quadrant 1. Pi is 3.14 something. 1.1. What's 3 pi divided by 2? 4 point what? And then 2 pi. Close enough for our purposes. This will help you when you're working on your calculator to know what quadrant you are in when you're in radian mode. We good? Now, what quadrant is this angle right here in? Is quadrant 2 an angle, a quadrant we were looking for? So that's one of our answers. That's this angle right here. Now I need an angle in quadrant 3. How? Don't do 3.14, do pi. Pi minus what? If we do pi minus that number, what's that going to give us? Good. That's going to give us that reference angle, which we're going to carry down into quadrant 4 or 3. No, I didn't want to use that in black. What is that? What's pi minus this? 0.174? 0.175? Then do pi plus that. You doing okay? You're waiting for the hammer to fall, so to speak. We only have one more problem left. So if it's going to fall, it's going to fall on this problem, right? I don't know. You're going to have to be the one to tell me. All right, one more. See, if I tell you no, and then you say you lied, because that's what you guys will say to me. Cotangent is that. What quadrants? Is that positive or negative? Positive. Oh, why 1 and 3? You don't know anything about cotangent. Because if the cotangent's positive, then the tangent is also positive, which happens in 1 and 3. Good. So I need an angle in quadrant 1 and an angle in quadrant 3. Let's go after this angle in quadrant 1, okay? What am I going to do in my calculator, because I don't have cotangent? So what is the, oops, what is the tangent of this, Jiminy Christmas, what's the tangent of this angle? So what is theta? Good. Tan inverse of, okay, run it. Please use your fraction command. What do you get? 0.175. Is that in quadrant 1? Because it's less than pi over 2, 1.57. So I know that one of my angles is 0.175 degrees. No, not degrees, radians, so don't put anything. I need an angle in quadrant 3. How am I going to get an angle in quadrant 3? Because what is 0.175 for this new angle? It's the reference angle. Good. 0.175. Please don't do 3.14 plus that. Use your pi key. Did a hammer fall? No. No, a hammer did not fall.